I already told you, and each then if you
रिकॉर्ड पर लगा लीजिए.
if you complete that here, then we will basically get that center of curvature of each surface as well as the distance from pole to that center of curvature, that we know, that is basically radius of curvature. Okay. And in addition to this, there are basically two more lens, two type of lens. That is, one is known as plano-convex. So in plano-convex lens, again you have two surface. This is actually plano-convex. Okay. Again you have two surfaces, you see, but one surface is basically plane and another is basically curved. So this surface will have some radius of curvature that is known as R1. It will have some, definitely it will have some finite value, right? For this surface, you see, this is not a part of any sphere, right? It's a plane. And if you can calculate that radius of curvature for this surface, let us assume this is R2. Then how much it will be actually, that R2? So R2 will be basically infinity, because this is not like a sphere, right? It do not have any curved structure. It is like a plane. Okay.
Yes.
So for that you will have that radius of curvature, that will be how much? Infinity. You have one more type of lens that is known as plano concave. So for plano concave, you have on curved surface, this is like this, and then you have another plane surface. So this is the plane surface, this is the curve, and have some finite radius of curvature, but plane surface radius of curvature in mind. Okay, and for non-convex lens, for both surfaces, you will have some finite radius of curvature, and also for normal concave lens, for both surfaces, you will have some finite values of radius of curvature. Okay, so this is all about your some terminology, and you will solve this problem based on this type of lenses. You have to choose this value. Okay, and you have to always keep in mind that incident ray direction, that will always be positive. Okay, and height of image or object, that you have to calculate from where? From principal axis. What is principal axis? Principal axis for lens, that is nothing but to join the line with two center of curvature. For this surface, you will have one center of curvature. For this surface, you will have one center of curvature. So if you join this two center of curvature by a line, that will be basically principal axis. Okay. Okay. So these are all of the terminology, and you have to keep in mind that focal length of one term that is known as focal length. And this is basically denoted by F. जो फोकल लेंथ है बेसिकली कॉन्वेक्स लेंस का जो होता है फोकल लेंथ, दैट इज बेसिकली पॉजिटिव, बट दिस इज ऑलवेज नॉट ट्रू. फोकल कॉन्वेक्स का बेसिकली पॉजिटिव होता है कहाँ पे? जब आपका लेंस एयर रखा है. इफ दिस कॉन्वेक्स लेंस इज सराउंडेड बाय एयर or the medium having low refractive index as compared to the lens, then it will be convex lens will be like a converging lens, or it will have some positive focal length.
सर आपकी आवाज नहीं आ रही.
सर आवाज नहीं आ रही सर.
सर आवाज नहीं आ रही है.
सर आवाज नहीं आ रही है.
सर के पास आवाज जा भी नहीं रही.
हाँ,
सेटिंग में करो भाई.
मैसेज कर रहा हूँ.
सर आवाज नहीं आ रही. सर आवाज नहीं आ रही।
मैंने सर से बोल दिया है, सतीश सर से वो कर देख रहे हैं।
Yeah. So we are solving.
स्टार्टिंग से
Is this clear? ये formula?
नो सर।
This
नो
formula?
सर।
सर स्टार्टिंग से कुछ नहीं सुनाई दे रहा था।
Okay, extremely sorry. So we'll discuss this formula. So what I said, suppose you have a from this formula you can calculate the focal length of the lens. So focal length, suppose you have a convex lens, and this lens having refractive index, that is NL. The refractive index of this lens, this is basically convex lens, is given, that is NL. And this lens is surrounded by medium having refractive index NM. Okay, the radius of curvature of this surface is R1, and for this surface curvature is R2. And a ray is coming and striking at R1. So I can write that focal length of this lens, and that will be how much, or reciprocal of focal length, that will be refractive index of this lens divided by refractive index of this medium, that is NM minus 1. Okay, then यहाँ पे आपको लेना पड़ेगा रेडियस ऑफ कर्वेचर. तो रेडियस ऑफ कर्वेचर, पहले जो रेडियस ऑफ कर्वेचर है पहले वाला, वो कौन सा रेडियस ऑफ कर्वेचर है, किस सरफेस का, जिस सरफेस में आपका रे पहले स्ट्राइक कर रहा है. किस सरफेस में स्ट्राइक कर रहा है, इस सरफेस में. सो हैव टू कीप R1. ठीक है, देन ऑन बाय R2, दैट R2 इज बेसिकली व्हाट, जो आपका सेकंड वाला सरफेस है उसका रेडियस ऑफ कर्वेचर. तो ये वाला बड़ा इंपॉर्टेंट है. ये कौन सा वाला होगा, ये जहां पे आपका रे स्ट्राइक कर रहा है. ठीक है,
ट्राई कर।
okay, so this is the significance of this formula. Now I have given a problem. So suppose you have a convex lens and both surface having same radius of curvature, that is 10 centimeter. The refractive index of this lens is given, that is 3/2, and this lens is surrounded by air having refractive index Nm equals to 1. So I have to calculate the focal length of this lens. So I will use this formula. So I can write 1 by f, that should be equals to how much, refractive index of lens, that is given 3/2, divided by refractive index of medium, that is on, minus on into
0.
okay, now you have a on by R1, right? So radius of curvature of this surface, that is given R1. ठीक है ना. तो जैसे आपका सपोज मान लो ये आपका पॉइंट ऑब्जेक्ट है, and ray is coming like this, ठीक है ना. So basically incident direction is what, this is the incident direction, and this direction is actually positive. ठीक है, इस सरफेस का जो रेडियस ऑफ कर्वेचर होगा किधर होगा, तो पोल से हम कैलकुलेट करेंगे. सपोज मान लो यहाँ पे इस सरफेस का जो इस सरफेस का सेंटर ऑफ कर्वेचर सपोज मान लो यहाँ पे है, तो पोल से ये जो डिस्टेंस है, आप किधर जा रहे हो, दैट इज पैरेलल टू इंसिडेंट रे, राइट. सो आई विल यूज पॉजिटिव वैल्यू ऑफ R1, दैट इज R1 is given 10 centimeter. So I'll use 1 by 10. Now you have a 1 by R2 also, right? But if you see for R2, radius of curvature of this surface, तो इस surface का suppose मान लो center of curvature somewhere here, suppose मान लो यहाँ पे for the sake of convenience. तो हम कैसे कैलकुलेट करेंगे रेडियस ऑफ कर्वेचर, फ्रॉम पोल, सपोज मान लो ये इस सरफेस का पोल यहाँ पे है, तो पोल टू सेंटर ऑफ कर्वेचर, and this direction, pole to center of curvature, that is anti-parallel to incident ray. So this direction is positive, but R2 actually anti-parallel to positive. So I have to use here minus 10. I have to use minus 10. Okay, So basically 3/2 minus 1, that is nothing but 1/2, and this will give you 1/10 plus 1/10, so that is nothing but 2/10. So these two will be cancelled and you will get 1/f equals to 1/10. So basically focal length of this lens will be how much? 10 centimeter. Is this clear what I'm saying?
Yes, sir.
Yes, sir. Now suppose you have another situation, problem number 2. Now this time you have a plano convex lens. This type of lens you have. And radius of curvature again for this refractive index of lens is given NL, that is 3/2, and the medium having refractive index, that is given NM, that is again 1. And radius of curvature of this surface is given R equals to 20 centimeter. Okay. Now you have to calculate focal length of this lens. Okay. You have to calculate focal length of this lens. Suppose you have a point object here, point object O. So again, I'll use same formula, 1/f, that should be equals to NL, that is 3/2, NM surrounding the refractive index 1 minus 1. Then R1. R1 will be the radius of curvature of this surface because ray will strike first here. Okay. And R1 will be positive because the center of this surface will be somewhere here, and you have to calculate distance from pole to this. So this direction is positive. So this is basically 1/20. And for R2 is the radius of curvature of another surface, that should be how much? That will be infinity. So 1/infinity, that will be 0. So it means 3/2 minus 1, that is nothing but 1/2, and then you have 1/20. So it means focal length of this lens will be nothing but 40 centimeter. Okay. Is this clear what I'm saying? Yes,
Is
sir.
it clear?
Yes, sir.
Now problem number 3. Suppose you have a convex lens. Okay. You have a convex lens, and the radius of curvature of both surface is given. Not given here, but they have given when they kept this. Okay. First of all, they have given the refractive index of this lens. Again, it is how much? 3/2. They have not given any radius of curvature, but they have given only refractive index of this lens, that is 3/2. Now, when they kept this lens in air, they have obtained that focal length, that is कितना? ये आपको focal length कितना मिला है? 20 सेंटीमीटर मिला है. कब? जब इस लेंस को कहाँ पे रखा है? एयर में रखा है. I mean this medium when when this lens is surrounded by air, they have obtained the value of this focal length of this lens, that is 20 centimeter. ठीक है ना? अब इस लेंस को सेकंड टाइम क्या किया गया है? एक लिक्विड में रखा है. सेकंड टाइम इसको एक लिक्विड में रखा गया है, एंड refractive index of this liquid, that is medium refractive index, that is 2. अब इसका फोकल लेंथ कितना हो जाएगा? सेम लेंस को कहां पे रखा है? पहले एयर में था, उस टाइम आपको फोकल लेंथ कितना मिला था? 20 सेंटीमीटर. नाउ दिस लेंस इज केप्ट इन ए लिक्विड. द रिफ्रैक्टिव इंडेक्स ऑफ दिस लिक्विड, that is NM, that is 2. Now you have to calculate the focal length of this lens. Okay, how will calculate? So first of all, when it is at air, जब एयर में है तो हम 1/f, what I can write? 1/f, that will be, बताओ. So I can write this is nothing but 3/2 NL by NM. NM कितना है? एयर के लिए 1 है, -1, and then you have 1/R1 minus 1/R2. Okay, and they have given that focal length when it is at air, that is nothing but 1/20. And let us assume this is your equation number 1. Is this clear? Now when this lens is kept in a liquid, okay, second case, when it is at liquid, then I don't know that focal length, that
I'll calculate. So I'll write 1 by f. That should be equal to how much? बताओ. Refractive index of lens, that will be 3 by 2. Medium का कितना हो गया अब?
2.
2. So it will be 2. Very good. Minus 1. Then you have 1 by r on minus 1 by r2. And let us assume this is your equation number 2. Okay. Now if I divide equation 1 by 2, then how much I'll get on the left hand side? Left hand side में क्या मिलेगा आपको बताओ? So left hand side you have 1 by 20 divided by 1 by f, and that will be how much? That will be, if you calculate, again I'll write. So 1 by 20 by 1 by f. ठीक है ना? So you have this factor 3 by 2 minus 1, 1 by r on minus 1 by r2, right? Then you have 3 by 4 minus 1, 1 by r on minus 1 by r2. This will be cancelled, right? And this will be basically nothing but f by 20. F by 20. And this will give you 3 by 2 minus 1 will be how much? ऊपर जो है, that will be 1 by 2, right? And 3 by 4 minus 1, that will be minus 1 by 4, right? So basically that is nothing but minus 4 by 2. So this is basically minus 2. So if you see, focal length is how much now? Minus 2 into 20. So basically this is minus 47. You have a convex lens. When you kept it in a liquid, जब इसका रिफ्रैक्टिव इंडेक्स लिक्विड का लेंस से ज्यादा है तो फिर आपको फोकल लेंथ क्या मिल रहा है? नेगेटिव मिल रहा है. इट मींस नाउ इट्स बिहेवियर इज व्हाट? इट विल बिहेव लाइक ए कॉन्केव लेंस. It will behave like a concave lens, or its behavior will be what? It will be diverging. It will not converge. ठीक है? क्या clear है? Is this clear what I'm saying?
Yes, sir.
Same thing used to happen in real example. Do you have any real example that you have a concave shape, but its behavior is like a diverging? ठीक है? So suppose मान लो आपका एक बकेट है ना? बकेट में वाटर है और वाटर के अंदर आपका सपोज मान लो बबल है, एयर बबल. The shape of that air bubble is basically what? ये जो एयर बबल का शेप होता है that look like a convex, but इसके इनसाइड क्या होता है? एयर होता है. इसका रिफ्रैक्टिव इंडेक्स कितना है? इट लुक लाइक ए कॉन्वेक्स लेंस. इसका रिफ्रैक्टिव इंडेक्स क्या है? 1 है. क्यों? क्योंकि इसका अंदर क्या है? एयर भरा हुआ है. और इसका मीडियम का जो आपका मीडियम में क्या है? लिक्विड है और वाटर है. इसका रिफ्रैक्टिव इंडेक्स कितना है? 1.33. ओके. So although the shape of this, now when that suppose मान लो ये रे इसके पर स्ट्राइक कर रहा है ना, ये पैरेलल रे स्ट्राइकिंग on this convex lens, sorry, on this bubble. इसका अगर इसका शेप क्या है? It look like a convex. So according to that convex lens का क्या कॉन्सेप्ट है? सपोज मान लो convex lens है, उसमें पैरेलल बीम स्ट्राइक कर रहा है ना, so it will be converge at a focal length point, right? At a point that is known as focus. But इस एयर बबल में अगर पैरेलल रे स्ट्राइक करेगा, so it will be diverge. It will not converge. It will not converge. So it look like it will come. It is coming somewhere from that behind point. So this is the real example that the shape of air bubble is look like convex, but due to its lower refractive index as compared to medium, that's why it will not converge that light beam. Actually, it will diverge. When that parallel beam strike on this air bubble, it will diverge. It will not converge. Okay, you have to keep in mind. So that focal length basically depends upon in which medium you kept that lens. This is the important message. Okay. Now problem number 4. So again you have a, suppose मान लो आपके पास you have a lens and its shape like this. Its shape is like this. Radius of curvature of this surface is r1, and radius of curvature of this surface is R2. Okay, and refractive index of this lens, again it is 3/2. Focal length is given, that is f equals to minus 24 centimeter. Okay, now we have a point object here. Okay, the medium in which this lens is surrounded, that is air. Okay, air में रखा है. Okay. And the refractive index of air, that is nm on. So what you have to calculate, also they have given that R2 is twice of R1. So I have to calculate the value of R1. You have to calculate the value of R1. How will you calculate? So you have a two surface, right? R1, R2. Relation between them is R2 equals to twice of R1. Refractive index of lens is given 3/2. Focal length is minus 24 centimeter, and the medium in which this lens is kept, that is air. Refractive index is how much? That is on. So you have to calculate the value of R1. So again, I'll use same formula. 1 by f, that will be how much?
-6.
So that will be 3/2 minus 1. That will be, again I'll get how much? 1/2, right? NL by NM minus 1. So 3/2 minus 1, that will provide you 1/2. Okay. Okay. Now 1 by R1. What will be the value of R1?
5, sir.
5 or minus 6. So you see, now your ray is striking like this, right? You have a point object here, ray is striking like this. So this direction is actually positive. Now you see, you have, suppose this is your surface, pole is somewhere here. Okay, and suppose इस surface का center of curvature इस side कहीं पे है. So you have to calculate that radius R1. So for calculating R1, you have to go from here to like this, in this direction. And this direction is actually anti-parallel to positive direction. So I have to choose -1 by R1. I have to choose -1 by R1 because this direction from pole to center of curvature, this is actually anti-parallel to positive direction. And same is true for second surface as well. Suppose you have a pole here, the center of curvature where it will be, you have to extend this surface, you will get center of curvature somewhere here. So again, you have to calculate R2 from pole to center of curvature. Again, you are coming anti-parallel to incident beam. So again, I have to use minus you already have, and you will get another minus because of opposite sign. So it will be basically 1 by R2. And R2 is nothing but twice of R1. Okay. And they have also given you focal length that is negative. So I'll use -1 by 24. That should be equals to 1/2 N2. This will be how much? It will be minus 1 by twice of R1. 1 by twice of R1. Am I correct? So it means if you solve this, basically -1 by 24, that should be equals to -1 by 4 R1. It means R1 is actually how much? R1 is actually 6 centimeters. But you have to keep in mind, you are calculating this R1 from here, from pole to in this direction. Okay, na? So one thing you have to keep in mind whenever you are solving this ray optics problem, the distance will always be measured from pole, and direction is positive. That direction is basically direction of incident ray. That is the main concept of solving this ray optics problems. Is this clear what I'm saying? क्या इतना clear है आप लोगों को?
सर R1
Yes, sir.
पॉजिटिव
हाँ बोलो.
सर R1 पॉजिटिव कैसे?
R1 पॉजिटिव कैसे?
हाँ,
नहीं
negative
देखो, R1 पॉजिटिव नहीं, R1 का वैल्यू पॉजिटिव, बट आपने ऑलरेडी माइनस रख दिया ना यहाँ पे, इसीलिए आपको पॉजिटिव मिलता है.
यस सर यस
क्योंकि आपने ऑलरेडी यहाँ पे पॉजिटिव नेगेटिव रख दिया ना, इसलिए आपको पॉजिटिव मिलता है. ठीक है.
ओके
ओके. सो कैन आई इरेज दिस?
यस सर
Then another important part of your JAM exam, that is focal lens formula. lens formula. This is also very important for your exam. I will not derive any formula here because I will not give you overburden, because I know you are already, you have so much of syllabus. So I will not derive, but I will tell you significance of each and every term. Okay, that is the main part to crack exam. So for lens formula, if you remember, for lens, for mirror, it was like 1 by v plus 1 by u equals to 1 by f. But for lens, it will be different. So for lens, that reciprocal of focal length, that is nothing but 1 by v minus 1 by u. Okay. And if you know that is focal length of your lens, v is the distance of image from where? Distance of image point from where? From optical center. Distance of image point from optical center. You know optical center, right? That is the, for most for 90% case, that is the center of your lens. And you know u is nothing but the distance of point object from optical center. And again, I am telling same thing, that direction of incident ray you have to keep, that is what? Positive direction. And for a lens, that magnification, if you remember, for mirror, it was like height of image by height of object. And same is true for lens as well. But this time, this can further be written as, for mirror, it was like what? It was minus v by u. But for lens, it will be v by u. So it is very easy to remember, because why no? Why? For mirror, if you remember, you have a plus sign here. So that's why you are getting minus sign. But for lens, you have minus sign, so you will have plus sign. Is this clear what I'm saying?
Yes, sir.
So this is the concept of magnification. And this height, from here you have to calculate that height. Height can always be calculated from principal axis. That you have to keep in mind. So अगर आपको positive मिल रहा है, इसका मतलब क्या है? That is upward from principal axis. If you are getting height negative, that is downward from principal axis. Okay. So based on this, let us solve few problems. Then I'll go to another topic. Suppose you have a convex lens. Suppose you have a convex lens. So let us solve this. This is a problem number 1 again. You have a convex lens, and the focal length of this lens is given, f equals to 10 centimeter. Okay, the point object is kept at a distance of 20 centimeter from principal axis. At a distance of how much? 20 centimeter from principal axis. Suppose this point object is O. Okay, then what you have to calculate? You have to calculate the position of image. Position of image, or V. Also, you have to mention the type of image. What type of image it is actually? So if you remember, for mirror, when U and V both are in same sign, then image will be what? That will be real image. That will be real image. Am I correct? अगर V भी आपको -30 सेंटीमीटर मिल रहा है, U आपका सपोज मान लो -15 सेंटीमीटर मिल रहा है, both are actually negative. और अगर सपोज मान लो both are positive, in that situation image will be what? That will be real image. But for lens it will be opposite. For lens, for real image, V and U should be in opposite sign. Okay, V and U should be in opposite sign, and for virtual image, V and U should be in same sign. Okay, let us solve this problem and we'll conclude that it will be actually real image. Okay, so again, so this point object is here, the ray is going like this to strike this mirror. So this direction is actually positive. This direction is actually positive. And this is actually convex lens, so obviously focal length will be positive. And this media, this lens is basically kept where? At air. So obviously this lens will be converging behavior, and it will be, that focal length will be what? It will be positive. Okay. So I'll use same formula to calculate V. So 1 by V minus 1 by U, that is nothing but 1 by F. It means I can write 1 by V, that should be equal to 1 by F plus 1 by U. So I can further write U plus F by UF. So reciprocal of V, that is nothing but U plus F divided by U into F. So further V can be written as UF divided by U plus F. Okay. So now we'll substitute that value. Now can you please tell me what is the value of U actually? It will be negative because your ray direction is positive, but you are calculating this distance of point object from here, from optical center to point, this direction. So this direction is actually what? That is anti-parallel to positive direction. So I have to use minus sign here. So I'll use minus 20. And you have f that is 10, then minus 20 plus 10. Minus 20 plus 10. Can you please calculate it? कितना आ रहा है? So this will give you basically how much? This will give you minus 200 by minus 10. So it will be basically 20 centimeter. Okay, so you can clearly notice that V is actually plus 20 centimeter, but U is actually minus 20 centimeter. So both are actually in opposite sign. So obviously that image will be what? It will be real image. And I can point that location of this image as well. So this direction is actually positive. So I have to go from optical center in forward direction. Okay, and it will be located somewhere here. And this distance from this to this will be actually 20 centimeters. And obviously it will be real image. Now how much will be the magnification? Magnification कितना आ जाएगा? बताओ. M will be how much? V by U. V is how much? 20 centimeter, and you have U is
Minus one.
exactly.
Minus one.
Okay. Okay. Excuse me. Class is going on. Class is going on. Okay. Then I'll solve another problem. Then you have a, suppose you have a, now this time you have a concave mirror. You have a concave mirror like this. Okay. This focal length is given. Focal length is basically f equals to 10 centimeter, and this lens is kept where? At AR. They mention this lens is here, or where kept? It is at AR. A point object is kept from optical center at a distance of 5 centimeter. Here you have a point object, that is 4, and this distance they have given, that is 5 centimeter. Okay. Now you have to calculate the position of image. Position of image you have to calculate. Okay. So obviously if you see, this direction is actually positive because ray will go like this. So this direction is actually positive. Okay. Now just I have derived that V can be written as, if you remember, UF divided by U plus F. Okay. Now can you please tell me what will be the direction of U? Can I write minus 5? I can, right? Because this is actually, you are calculating from that U, position of object from here optical center. So this direction is actually what? This is anti-parallel to direction of incident ray. So I can use minus 5. And for concave lens in AR, so it will be how much? It will be actually कितना लिख सकते हैं बताओ? राजकुमार, सौरदीप, राजकिशोर, can you please tell me? Sekar, Dhiraj, Anju.
Sir, 10.
क्या मैं बोल रहा हूँ जो फोकल लेंथ है कितना लिख सकते हैं? ये कौन
minus 10 centimeter.
minus 10 because
Minus 10.
they have given 10, but they mentioned that this lens is actually kept where? कहाँ पे रखा है आपका? AR में रखा है. So you have to use minus 10 because you know that concave lens we have like a diverging lens at AR. So you have to use minus 10. Then you have minus 5. Use minus 5 and F is how much? Minus 10. कितना आ रहा है चेक करो. If you calculate this will be where? Minus 3.3.
और है सर.
So this is actually location कहाँ पे होगा? ये आपका ऑप्टिकल सेंटर है. इधर से किधर जाना पड़ेगा? राइट या लेफ्ट? लेफ्ट में जाना पड़ेगा. क्यों? क्योंकि आपका माइनस में आया है. And that will be here. That will be image will be somewhere here. And that distance from optical center to image, that will be how much? 3.33 centimeter. And what type of image it is actually? Obviously it will be virtual, right? Virtual इसलिए है क्योंकि आपका V माइनस में है and U also minus. U is minus 5 centimeter, V is minus 3.3 centimeter. So that image is actually what? It is virtual image. Is this clear what I'm saying?
Yes, sir.
Okay. Now we have another problem. Okay, suppose you have a convex lens. Problem number कितना है? Problem number है, बताओ आप लोग, भूल गया. 3, right? Suppose you have a convex lens. This is your convex lens. This focal length is given f equals to 10 centimeter. ठीक है? And a point, ये object is kept. Suppose this is the principal axis. है ना? ये object is kept at a distance of 15 centimeter. कितना दूरी पे रखा है? 15 सेंटीमीटर दूरी पे रखा है. और इसका हाइट जो है, दिस ऑब्जेक्ट, ये ऑब्जेक्ट का हाइट है 2 सेंटीमीटर. ठीक है? So you have to calculate basically height of image that you have to calculate. Convex lens, focal length 10 centimeter. Okay, distance of that object from optical center, that is 15 centimeter. Height of object is 2 centimeter. You have to calculate height of image. I'll calculate. So again, I'll use to calculate that height of image. What I have to calculate? I already know that u, right? U is how much? Minus 15 centimeter. And I know this formula. Height of image divided by height of object. That is nothing but for lens, it will be v by 2. So I know u minus 15 centimeter. I can calculate that v, and they have given you that height of object. So I can easily calculate height of image. Before that, I have to calculate v. To calculate v, I will use this formula: 1 by v minus 1 by u, that is 1 by f. Okay, and it means v equals to how much? Uf divided by u plus f, that I have used many times. Okay, u is minus 15 centimeter, f is 10 centimeter, divided by minus 15 plus f.
4 आ रहा था कितना?
Exactly, minus 4 or plus 4? Minus आएगा, right?
-4.
If you calculate, you will basically get 30 centimeter. This v.
Yes, sir, got it.
Very good, very good. So it means v by u, height of image, that will be height of object that is given, and this will be positive because principal axis के ऊपर है. So I can use, this will be 2 centimeter. Okay, and then you have v, that is 30 centimeter, divided by u. U is minus 15 centimeter. So this will be cancelled. You will get 2. So this will be basically minus 4. Then how it will look like? It will be from optical center to at a distance of 30 centimeter, this image, and it will be looking like this. ये कितना हो जाएगा आपका ये? This is basically 4 centimeter. Is this clear what I am saying? ये डिस्टेंस कितना हो जाएगा? यहाँ पे आपका इमेज रहेगा, ये डिस्टेंस आपका 30 सेंटीमीटर हो जाएगा, and it will be inverted. Okay, is this
Yes.
clear?
सर ये u minus 15 कैसे रखें?
सॉरी, u minus 15 इसीलिए है, देखो आपका यहाँ पे पॉइंट ऑब्जेक्ट है, तो रे विल स्ट्राइक लाइक दिस. तो ये वाला डायरेक्शन जो है आपका पॉजिटिव डायरेक्शन है, राइट? एंड यू आर कैलकुलेटिंग यू. यू कहाँ से कैलकुलेट करोगे? यू हैव टू ऑलवेज कैलकुलेट फ्रॉम ऑप्टिकल सेंटर टू डिस्टेंस ऑफ ऑब्जेक्ट. तो आपको किधर जाना पड़ रहा है? ऑप्टिकल सेंटर से इधर जाना पड़ रहा है, एंड दैट इज एक्चुअली एंटी पैरेलल टू पॉजिटिव डायरेक्शन. So you have to use minus. You know, in ray optics, main thing actually you have to choose sign. That is really important. The formulas are so simple. इतना सारे फॉर्मूले है, बहुत सिंपल है. 1 by v plus 1 by u equals to 1 by f. Half f equals to r by 2. 1 by v plus 1 by u equals to 1 by f. m equals to v by u. These are very simple formula ना. सारे फॉर्मूला जो है बहुत सिंपल है, बट मेन चीज क्या है? आपका साइन कन्वेंशन है. एंड फॉर दैट आल्सो वेरी सिंपल रूल इज देयर. You have to always choose the direction of incident ray, that is your positive direction, and other will be, if any direction is anti-parallel to incident ray, that will be your negative direction. Okay.
Yes,
Yes,
sir.
yes. Okay. We have 5 minutes more, right? I thought today I'll finish your course, but I think it's impossible. I have to take one more class. Okay, now I'll discuss that refraction from spherical surface. Oh, sorry, I forgot to tell. that focal length for combination of lengths. Suppose you have a combination of lengths. Combination of a lenses. Suppose you have a two convex lens. This is your convex lens, and you have another convex lens. They are in contact. The surfaces are touching to each other. And let us assume this is the principal axis. This is the principal axis. Focal length of this lens, suppose this is f1, and the focal length of this lens is f2. So how much will be the focal length of resultant? सारे combined जो lens है इसका resultant focal length कितना हो जाएगा? So I can convert these two lenses into a single lens, and focal length of this lens is Fe. Okay. So equivalent focal length of these two lenses, I can write 1 by Fe, that will be 1 by f1 plus 1 by f. When they are basically contact, जब दोनों लेंस आपका contact में है, तो you can calculate the focal length of whole, focal length or equivalent focal length of these two lenses can be written as 1 by Fe. Fe क्या है आपका? Equivalent focal length, and that can be depends upon what? Focal length of individual lens. Again you have to keep sign. जैसे आपका f1 f2, इसका अगर ये concave है तो आपको क्या लेना पड़ेगा? माइनस लेना पड़ेगा. Sorry. And convex है तो फिर क्या आपको पॉजिटिव लेना पड़ेगा, है ना? So you have to keep that sign here also. ठीक है, जैसे मैं आपको एक एग्जांपल देके इसका सिंपल कर देता हूँ प्रॉब्लम को. सपोज मान लो एक प्रॉब्लम है कि भाई आपके पास दो लेंस है, दो लेंस दे आर टचिंग टू ईच अदर. एक का जो फोकल लेंथ है सपोज मान लो 5 सेंटीमीटर है. ठीक है, ये आपका क्या है? कॉन्वेक्स लेंस बोला है. आपका क्या है? ये आपका कॉन्वेक्स लेंस बोले है. एंड दूसरा जो है लेंस है उसका फोकल लेंथ है 10 सेंटीमीटर, and they mention this lens is actually concave, and these two lenses are touching to each other. Okay, so first you have to calculate that equivalent focal length. You have to calculate Fe. Very simple. Then you have to say that behavior of this lens, जो आपका combined lens है उसका behavior किस तरह की होगा? एक converging behave शो करेगा और diverging behave शो करेगा. That you have to tell. Third thing you have to calculate. What you have to calculate? You have to calculate the position of image. Position of image V. Position of image means V, that you have to calculate कब जब आपका पॉइंट ऑब्जेक्ट 30 सेंटीमीटर दूरी पे है. 30 सेंटीमीटर दूरी पे है. कहां से? कॉम्बाइंड लेंस से 30 सेंटीमीटर दूरी पे है, तब आपको कैलकुलेट करनी है. ये कैलकुलेट करनी है, पोजीशन ऑफ इमेज कैलकुलेट करनी है. कैन यू एबल टू कैलकुलेट? नॉट 30 सेमी, जो आपका u गिवन है दैट इज गिवन एज 15 सेंटीमीटर. अगेन आई एम रिपीटिंग यू. सो यू हैव टू लेंसेस. One is convex, another is concave, and their focal length is given. They are touching to each other, and they are basically kept in here. So you have to calculate focal length of equivalent lens, है ना? पूरा combined system का focal length calculate करना पड़ेगा. Behavior of combined lens.
-6 आ रहा है सर.
हाँ?
-6.
Great. -6 आ रहा है, आपका -10 आएगा. Sorry, आपका 10 आएगा, +10 आएगा. I'll tell you.
नहीं वो B
10 आ रहा है सर.
इमेज
F10.
F तो 10 आ रहा है लेकिन इमेज B आ रही है. वो B मतलब -6.
I think it will be 30 centimeter. You have to mention, you have to calculate. Okay, I'll calculate. So पहले आपको कैलकुलेट करो इक्विवेलेंट फोकल लेंथ. सो 1 by Fe, that will be how much? बताओ आप लोग. तो कॉन्वेक्स के लिए क्या रखोगे? 1 by 5 रखोगे. कॉनकेव के लिए -1 by 10 रखोगे.
-10
तो ये कितना आ जाएगा आपका बेसिकली?
+10. F equal to +10.
If you will be +10, it will be, so it will be basically 1 by 10. So I can write that equivalent focal length, it will be 10 centimeter. So obviously focal length is actually positive, so it will behave like a converging behavior so करेगा, right? Okay, now you have a focal length, sorry, equivalent lens like this. इसका focal length कितना है? FE है, that is कितना मिला है आपको? 10 सेंटीमीटर मिला। और आपका जो पॉइंट ऑब्जेक्ट है कहाँ रखा है? ऑप्टिकल सेंटर से कितना दूरी पे? 15 सेंटीमीटर दूरी पे रखा है, ठीक है ना? So you have to calculate that position of image. Again, I will use same formula. So 1 by V minus 1 by U equals to 1 by F. यहाँ पे 1 by FE हो जाएगा। इसका मतलब V कितना हो जाएगा आपका? FE U डिवाइड बाई FE प्लस U, ठीक है? इसका कैलकुलेट करना और मेरे को शेयर करना है। आई एम स्टॉपिंग हियर, ठीक है? कैलकुलेट इट एंड टेल मी। It's very simple mathematics is there, right? You can. Okay, tomorrow I'll finish your course. Okay. I thought today I'll finish, but not possible. Okay.
सर
You have doubt?
सर वो आपने प्लेन मिरर पढ़ाया था, उसका वो क्लास नोट्स में अब वो है ही नहीं।
क्लास नोट्स है ना आपके पास?
नहीं, वो किताब तो है लेकिन उस बुक में है नहीं है प्लेन मिरर।
अच्छा, मटेरियल में?
हाँ
मटेरियल में प्लेन मिरर का बेसिकली आई विल प्रोवाइड यू। ओके, that is not good, that much important. If you need, I'll provide you, don't worry. Okay, just give me a message, I'll provide you.
yes.
Sir, V value 30 centimeter.
30 centimeter na? Great, very good.
Yes, sir.
Very good.
Teeth, sir.
Good, great, very good. Okay, I should stop here.
Thank you,
Okay,
sir.
thank you.
थैंक यू सर।